Hi dear viewers, welcome to another session of Informatics for BA English. In today's session, we are going to discuss about network topologies and types of networks. First, let us start with network topologies. What is a network topology? It refers to the way in which networks are physically connected together. When you are going to connect different systems based on certain different types of networks, we can physically connect together, and there are some way in which you can connect the systems together. So it refers to the topology, network topology. It refers to the way in which networks are physically connected together, how the networks of systems are physically connected together. The basic topologies are: first is bus topology, second is ring topology, then there is a star topology and mesh topology. And it is also a geometric representation of relationship to one another. It refers to the way in which the network systems are connected, and it is also the geometric representation of the relationship to one another. When you are connecting more than one system together using cables and other network devices, how you are going to organize those systems? There are different types of organization, different types of way in which these systems are interconnected, right? And if you are connected several systems, then there may be a relationship between them. There may be a relationship between each of the systems. And different types of topologies are: first is bus topology, second is ring topology, third is star topology, and fourth is mesh topology. These are the four main categories of network topologies. Let's see one by one. First, let us see what is bus topology. In the name itself, you can guess what is bus. In case of bus topology, all devices share single communication line or cable. In this kind of topology, there should be a single line of communication. There should be a single communication line. Bus topology may have problem while multiple hosts sending data at the same time. So what is this problem? In this bus topology, there is a single line of there is a single communication line. This is called as communication line. And to this communication line, each and every computer system take part in that network will be connected. There you can see there are 5 systems here. All these 5 systems are connected to a single line, and data flow may be from left to right or right to left. That is depends on the path where which the one system is going to send data to another system. And there will be a terminator at the end of this communication line. This is called as terminator. So what is the problem here is, if more than one system are trying to send the data at the same time, there may be a problem. You cannot send that. Therefore, bus topology either uses CSMA bar CD technology or recognizes one host as bus master to solve the issue, right? So in this problem, the problem can be solved by using a technology. That technology is called as CSMA bar CD technology, so that only one computer can send data at a time. Or another way you can solve this problem is to recognize one host as a bus master to solve the issue. You can save one system as a master, bus master, so that it will always look for the data, or it will always look for the flow of data. if any data is flowing through the line, the others request or others data is actually stopped, or it will reject the other data flow, right? So it will tell that you cannot send data right now because there is a flow of data, right? So it is one of the simple forms of networking where failure of a device does not affect other devices. What is the advantage of bus topology here? The advantage of bus topology is, if any system got failed during transmission, what happens? The others won't affect. Suppose, for example, this is the first system in our network. For some time, if first system is got failed, the other system won't affect. Suppose one data is flowing from left to right and from 2 to 3 or 2 to 5, and if first system is got failed, it won't affect other systems. Okay, so it is one of the simple forms of networking where failure of a device does not affect the other devices. But failure of the shared communication line can make all other stop functioning. But failure of the shared communication line can make all other devices stop functioning. Here I told you there is a communication line. If there are any problem with communication line, then you cannot send data. No computer can send data if the communication line has been stopped or communication line has been damaged. So this is one of the biggest disadvantage of a bus topology. Both the ends of the shared channel have a line terminator. You can see here there is a line terminator at first and also at the end. The data is sent only one direction, and as soon as it reaches the extreme end, the terminator removes the data from the line. So at a time, I told you can send one data at a time. Okay, and it should be in either direction, right? It should be from left to right or right to left, not in both directions. Okay, so once it reaches at the end, suppose for example we are transmitting data and the flow of data will be, direction of data is from left to right. We are transmitting from first system and it flows through this line and it reaches ends. Once it will be going to each and every system. Once it reaches at the end, that is at the terminator, the data will be removed, right? So this is about bus topology. So bus topology means it's a simple form of topology where you can connect systems in a single where you can connect different systems to a single communication line, and you can send data only one data at a time, and the movement of data may be from left to right or right to left, not in both directions. And at the end of communication line, in both the ends there will be a terminator. Okay, and the advantages of this system is you can easily construct, and if one system got failed in the in this network, the other system won't affect that, right? And disadvantages of this systems or this network is, if any problem happened during communication in communication line, that means if communication line is got damaged, then the entire system will stop sending the data. That means the functioning of the network will be lost, right? That is one disadvantage. And if you can send only one data at a time, that too in one direction, okay, that is a disadvantage. And then the line, there is a line terminator at the both ends. The data is sent only one direction, and as soon as it reaches the extreme end, the terminator removes the data from the line. If it reaches the extreme end, it may be at the leftmost end or rightmost end, data from the data will be removed. The terminator removes the data. So what is the purpose of terminator? The purpose of terminator is to remove the data when it reaches. When the data reached the terminator, it will remove the data. That is the purpose of terminator. So this is about bus topology. So let us move on to star topology. What is star topology? All hosts in star topology are connected to a central device known as hub device using a point-to-point connection. That is, there exists a point-to-point connection between host and hub. The hub device can be any of the following. So what is that? All the hosts are connected to a device, central device. What is the central device? That central device is called as hub. So that there will be a point-to-point connection. Suppose first system is having connection to the hub, that is a point-to-point connection from here to here, and here also you can see there is a connection. So all these systems are connected to a central point, and it will see as a star, right? It will shown as a star. It will point, all the systems are point to a central device. That central device is called as hub. Then the hub device can be any of the following. That is, in layer 1 we use device such as hub or repeater. We can use it as a repeater or hub. In layer 2, that is layer 1, layer 2, layer 3 means in OSI reference layer. In OSI reference, we know that there are 7 layers in OSI reference. In OSI reference layer there are 7 layers. In layer 1, device such as hub or repeater can be used. In layer 2, device such as switch or bridge can be used as a hub. Then layer 3, device such as router or gateway used as a hub. So all the systems are connected to this central device. In each layer the device may be changed, but the concept is same. Okay, it will act as a hub. Okay. As in bus topology, hub act as a single point of failure. Hub is act as a single point of failure. What do you mean by that? If hub fails, connectivity of all hosts to other host fails. So if hub lost their connection, or if hub damaged or failed, it will affect all the systems. You cannot communicate with any other system in that network if hub is failed. But in case of any system has failed in that network, it will not affect other systems. Okay. Every communication between hosts take place through only the hub. Star topology is not expensive as to connect one more host. Only one cable is required and configuration is simple. The advantage is it is very simple to connect. If you want to add more number of hosts to this system, you need a cable, that's it. There will be a port in hub, you can directly connect it to port. Okay, and it is not expensive. You can add as many hosts you need. Okay, as many hosts you want, you can add it. It is very simple. You require only one cable. Okay, the configuration is also very simple. But the only disadvantage is if host got failed, if the hub got failed in the network, then the entire system will be affected. You cannot send any data between the systems, okay, or between the hosts. That is about star topology. I hope you understood. It's like a star structure. When you move on to ring topology, what is ring topology? In ring topology, each host machine connect to exactly 2 other machines, creating a circular network structure. It will connect. The structure of this network is like a ring. What do you mean by ring? Each system is connected to at least 2 other systems. Each system is connected to exactly 2 other systems, right? The left or right side, on the left side or right side, you can connect. So exactly 2 systems you have to connect, and if you connect in that way, you will get a structure. That structure is like a ring, right? When one host tries to communicate or send message to a host which is not adjacent to it, the data travels through all the intermediate hosts. For example, here in your figure you can see this is a machine. This is a computer system take part in this network. Suppose I want to send data from this machine to this machine. the machine immediately below the current machine, but this machine is not adjacent to this. The adjacent machines are this one and this one. This is not adjacent. So how do you send data from this machine to this machine? Either you can send through this path or you can send through this path, but in this path there is another system. So the data will flow from here to this system and from this system to this system, right? So in ring topology, each host machine connect to exactly two other systems. You can see there are two systems here, and creating a circular network. When one host tries to communicate or send message to a host which is not adjacent to it, the data travels to all intermediate hosts. This is the intermediate host, and to connect one or more hosts in the existing structure, the administrator may need only one more extra cable, right? If you want to add one more system here, you can add it. The administrator needs extra one cable. That's it. Okay. Failure of any host result in failure of the whole ring. So in this case, the biggest disadvantage is if one system failed, then the entire system or the entire network will be failed, right? Thus, every connection in the ring is a point of failure. So every connection in this ring is a point of failure. There are methods which employ one or more backup ring. There are methods to take the backup. There are methods which employ one or more backup ring. That is also possible. So this is about ring topology. So in ring topology, the computer systems are connected in such a way that one system should connect exactly to other systems, right? And one system want to send a message or communicate with another host which is not adjacent to that machine, then the message will come through all the adjacent or all the intermediate host, right? And the disadvantage of this topology is when any system got failed during the transmission, then the entire network will be stopped, right? And that is the biggest disadvantage, so that each and every system is a point of failure. And when you want to add one more system to this network, it is very easy. The administrator needs only one cable, right? You can disconnect from one system and connect to this system, and from this system you can connect to another system. So it needs only one cable to connect. So it is very easy. That is about a ring topology. Then when we go to mesh topology, what is mesh topology? In this type of topology, a host is connected to one or more multiple hosts. This topology has host in point-to-point connection with every other host, or may also have hosts which are in point-to-point connection to few hosts only. So in this kind of topology, a system in that network will be connected to all other systems. One system is connected to all other systems, and that connection is point-to-point connection. Suppose the system S1 is connected to S2. Suppose this is S1 and this is S2. S1 is connected to S2, and also S1 is connected to S3. Suppose this is S3, and also system 1 is connected to S4 and system 1 is connected to S5. All this connection is point-to-point connection. There is no intermediate host in between. So this is point-to-point connection, right? Host in mesh topology also works as relay for the other hosts which do not have direct point-to-point links. Mesh topology comes in two types. There are two types of mesh topology: full mesh and partially mesh, right? What do you mean full mesh? All hosts have point-to-point connection to every other host in the network. Thus, for every new host, n minus 1 by 2 connections are required, right? So n minus 1 by 2 connections are required if you want to connect with all other hosts in that network, right? That kind of network is called as full mesh. It provides the most reliable network structure among all network topologies. It is a reliable network topology. And what is partially mesh? Not all hosts have point-to-point connection to every other host, or connected to each other in some arbitrary fashion. This topology exists where we need to provide reliability to some host out of all. Suppose in this case partially mesh means not all hosts have point-to-point connection. Suppose this is system 1. It may be a point-to-point connection from system 1 to system 2, system 1 to system 5, system 1 to system 2, right? And it doesn't have any point-to-point connection with system 3. So this is called as, suppose this communication line is not there, then this kind of mesh topology is called as partially mesh. So what is the advantage of partially mesh? Suppose if you want to give more importance, or if you want to give reliability to some host, not all the host, reliability to some host, then you can connect point-to-point connection to that host. That host means where we give reliability. For example, I need a reliability for system 2, system 3 and system 5, 1, 2, 3, 4, 5, and I want to give reliability to system 2, system 3 and system 5. I don't want to give to system 4. So in that case I can connect the systems. This system can be connected to this one and this one, not to this one, and this also, this can connect to this one and this one, not to this, right? So that is called as partially mesh topology. So what is mesh topology? Mesh topology is a kind of network topology where one system is connected to all other systems. One system is connected to other systems. It may be full or partial, right? That is depends on the reliability. If you give full mesh, if you give the first type of mesh, that is full mesh, all the systems are connected to all other systems. Every systems are connected to all other systems. But in partially mesh, every systems are connected to not all the systems where we give reliability, right? This is called as mesh topology. So in this case, if one system got failed, it does not affect other systems, you can communicate, right? But including another system is a difficult task. You need more cables, okay? And all the systems communication is point to point. There won't be any intermediate host, right? Here you can see, if you want to communicate with the third systems, you don't want to go from 1 to 2 to 3. You have a direct connection. This is called as point to point connection. That is about mesh. That is about topologies. Next, let us see what are the different types of networks. Different types of networks. Those are different types of topologies. Then let us see what are the different types of networks. And there are different types of network called local area network, wide area network, and metropolitan area network. Local area network, wide area network, and metropolitan area network. How you are going to organize networks to go, to send and receive the data. That is called as types of networks. Local area network, wide area network, and metropolitan area network. In each network you can use any of the topology. You can choose bus topology or star topology or mesh topology, anyone you wish, right? Let us see local area network. What is local area network? This is an example. You can see there is a hub over there, and the systems are connected, and there will be a server. There are client machines, there are laptops, etc. Right? A local network is a computer network, and it interconnects computers within a limited area, such as a residence, school, laboratory, university campus, or office building. Right? So that network connection is limited here. Right? You can connect several systems within a span of area, within an area where it may be a residence area, it may be school, it may be laboratory or university campus or office building, etc. That is called as local area network. The time or the limit of network area, or the area is limited for this. It is local, and the number of systems are less, and the area it covers the network is also less. That is called as local area network. Depending on the needs of the organization and type of technology used, a LAN can be simple like 2 PCs and a printer, or it can be extended to include the entire company and its audio and video peripherals. This is also possible. I told you the area is less. That means you can connect systems in a school, right? You can connect the systems of a school. You can connect systems of an organization, a residence, or you can connect systems which is there in the office, right? It may be starting from 2 systems to any number of systems, right? You can connect, if you connect 2 systems via cable adjacent to it, then it is called as a local area network. And also you can connect a printer, you can connect audio devices, you can connect video devices, etc. You can connect any kind of devices to this network, right? But it should be limited. The area is limited. That is called as local area network. It is less costly as it built with inexpensive hardware such as hub, network adapters, and Ethernet cables. Advantages: it is less costly. Okay, as a built because it built with inexpensive hardware, not expensive hardware. Inexpensive hardware such as hub, network adapters, and Ethernet cables. And the data is transferred at an extremely fast rate in local network because the area is very less, limited area, so that the transmission rate also got higher. Maximum transmission rate you will get. The data transferred an extremely faster rate. You can transfer the data extremely faster, right? And local area network provides higher security as well. It provides higher security. Yes, that is about local area network. Then let us move on to wide area network, that is called as WAN. Here you can see many local area networks are connected together. Many local area networks are connected together in a large area, right? A large area, many networks are connected together. I can give you a simple example for local area network, like if you went to a shopping mall, or if you went to a mall where you can purchase many items, right? There you can see there are systems in counter. A billing is possible at any counter. The billing is possible. How it is possible? Because all the systems in that building is connected. All the systems in that building is connected. There may be a system in the first floor, there will be a system in the second floor, there may be some systems in the third floor, right? All these systems are interconnected, right? So when you take a bill from the third floor, you purchase some items in third floor and put a bill on the third floor itself, but that bill will be received in the first floor when you exit, right? Because all the systems are interconnected, right? That is a local area network. Then what about wide area network? Such type of local area networks are connected together. For example, if one person is having 10 shopping malls in Kerala, so all the 10 shopping malls computer systems want to connect. He wants to see the status of business. He wants to see the status of business in his office. Suppose in his office is in Ernakulam or Kochi. He wants to see the status of all other shopping malls, you want to see the status of or the performance of each and every shopping malls, then he can see in his system if his system is connected to all the shopping malls local area network. This is an example of wide area network. The different number of local area networks are connected to a single network. In its simplest form, a wide area network is a collection of local area networks or other networks that communicate with one another. A wide area network is a network that extends over a large geographical area. You can extend it to a large geographical area such as states or countries, not beyond that, such as states or countries. A wide area network is quite bigger network than LAN, obviously, because LAN is situated in a single in a small geographical area, but wide area network is bigger than local area network because it is having the area in which it covers is large. Okay. A wide area network is not limited to single location, but it spans over a large geographical area through a telephone line, fiber optic cable or satellite links. You can connect through any media. You can connect through telephone line, you can connect through fiber optic cable, or you can connect through satellite wireless connection. The internet is one of the biggest WAN in the world. You know what is internet? Internet is connected to each and every point of the world, each and every area of the world. So internet is the biggest WAN, wide area network. The wide area network is widely used in the field of business, government and education. Right? Business, government and education. Then there is metropolitan area network. This is bigger than wide area network. What is the advantage? Here in this figure you can see the LANs are connected to a MAN, right? In its simplest form, a metropolitan area network is a network that covers a larger geographical area by interconnecting a different LAN to form a large network. It's not like a wide area network. The area which covers is higher than wide area network, a metropolitan area network. Government agencies use MAN to connect to the citizens and private industries. Okay, and in MAN, various LANs are connected to each other through a telephone exchange line. So in this case, the LANs are connected through telephone exchange line. The most widely used protocols in MAN are RS-232, Frame Relay, ATM, ISDN, OC3, ADSL, etc. It has higher range than local area network. Right? Higher range means the area in which it covers is higher than local area network. That is about metropolitan area network. So you may be confused the difference between what is the difference between metropolitan area network and wide area network. Wide area network is a large network where you can connect multiple LANs together. In metropolitan area network also you can connect different LAN network, local area networks together. The difference is that metropolitan area is bigger than that of wide area network. It is exclusively used for certain purposes in government agencies, etc. And it is connected through telephone lines, telephone exchange lines. Okay. Let us move on to wireless networks. So far we studied about wired networks. Now we move on to wireless network. Wireless networks. Wireless networking is a method by which homes, telecommunications network and business installations avoid costly process of introducing cables into building or as a connection between various equipment locations. So the invent of wireless network is because of the cost of implementing the network using cables. When I use cables, it will be not only cables, there will be supporting network devices as well. So it will be costly when you want to implement a network. So to reduce that cost, we are going for another kind of network, which is called as wireless network. It is a method by which homes, telecommunication networks and business installations avoid costly process of introducing cables into a building or as a connection between various equipment location. You can reduce that cost of various equipments and cables. Admin telephone communications networks are generally implemented and administered using radio communication. Okay, you can go for radio communication. This implementation takes place at the physical level, right? That is physical layer of OSI reference model. Okay, this implementation means wireless network implementation is happening at the physical layer. The wireless computing systems are classified into two, such as fixed wireless systems and mobile wireless system. What is fixed wireless system? Fixed wireless systems do not support mobility of their computing equipment. Suppose if you have certain equipment to connect through wireless, if you want to connect a wireless connection, you need some certain equipments. That equipments will be fixed. You cannot move that equipment. For example, there is a wireless adapter or wireless adapter in your computer lab, and when you move that wireless adapter to another location, you won't get data in that computer lab. Suppose your purpose is to send data, or your purpose is to get the connection in that computer lab only, and when you move that device to another location, you won't get the connection, right? That is called as fixed wireless system. Do not support mobility of their computing equipments. Mobility means movement of their computing equipments. Mobile wireless systems support mobility of computing equipment used to access resources of wireless network. In this case, if you move the wireless network also, you will get the data. For example, your mobile phone. Suppose your mobile phone is used as a wireless adapter to your computer system, your laptop. When you are traveling to another place from your hometown, if you want to use your internet connection over there, you can move. You can take your mobile phone, you can take your laptop, you can move there. You can use the same internet connection there also, right? That is called as mobile wireless systems. So there are two kinds of wireless systems: fixed wireless system and mobile wireless system. The different methods of wireless transmission are use of electromagnetic spectrum, infrared and millimeter waves and light waves. So different transmission methods can be used. You can use electromagnetic spectrum, you can use infrared, millimeter waves and light waves. Any kind of wireless transmission you can use. So this is about wireless network. Wireless network. There won't be any cable to communicate, right? That is called as wireless network. That's it. Thank you. If you have any doubts, you can share me through YouTube. Thank you.